I think we've got two great talks tonight. I'll just let Josh get it started. We'll have some announcements in the middle. And everyone welcome Josh Hawkins, who's going to talk to us about Cabal, build systems, and getting started with Haskell.
Hello. Thank you. Can you guys hear? There we go. Can you guys hear me pretty well? Okay, perfect. So tonight I'm going to be speaking with you guys about Cabal. All the things from init to distribution. I'm going to throw in a little bit of testing and also some benchmarking as well. Just a little bit about myself. I'm not a professional Haskell programmer. I'm kind of more of a polyglot programmer. I started out working in C# and Ruby on Rails, a lot of web development, some JVM stuff. And then I worked on a larger F# project for a little while. Hooking in with WPF, got really excited about functional languages and really like some of the features that are present there. So just to start out, I guess shameless promotion for Andrew's language, formal. It's what I've been doing most recently to get more involved in Haskell. It's a really fun compiled to JavaScript language. It has a lot of the features of Haskell, including strong typing, and they're all listed here. It's functional, it's strict, it's expressive, and it's fun. So anyway, the first time you come to, well, in my experience, moving around to different languages, I will pick up some of the features of the language and get really excited about it. Say some of those features might be type classes or purity or, I don't know, referential transparency, whatever, and start writing some code in that language. And then I realized that I kind of want to give back to the community, or I want to write something useful, and I pitch it to people I work with or something like that. And they asked me, well, how do you go about structuring this code? How do you distribute it? And all of these things. So Cabal can be kind of a stumbling block for beginners. So this is going to be a simple talk on how to initialize and get started. So what is Cabal? Well, it's an acronym. It stands for a common architecture for building applications and libraries. It describes a common way for you to categorize and package and distribute your code. And at its root, it's just a library that exposes a lot of different modules that you can find helpful in doing so. It also will describe your build, what conditions you'll need to meet in order to build your targets, and it provides an easy and expressive way to do this. And let's see. And if you're going to have a way to describe how to distribute your packages, then you probably also need to have some sort of upstream package distribution system. That would be HackageDB in this case. It's going to be a upstream repository for all the software that us as developers might want to get out there for other people to use. And it provides a nice clean web interface for viewing the documentation and the modules that are exposed, and also linking to other dependencies. So how do you use this? Well, the other part of the infrastructure, the larger Haskell infrastructure for doing this, is Cabal install, which is the command line interface for using Cabal, the library. It provides a lot of Unix-y sort of commands that you would expect. It also provides, I'm going to say, three main groups of commands that you might want to use. One being package management itself. That would be like installing, downloading, and checking out what dependencies are available. And then also package development, which would include things like configuring and building your project and testing and benchmarking. And then sharing it with the world, which would be things like how to package it and how to upload it to HackageDB. So first steps, I suppose. Maybe you would want to know how to explore all the packages using this tool. The first thing you'll probably want to do upon running it is to update the package cache and get the list of packages, and then install, unpack, and then Haddock can also provide some details on what the package does. So first up, Cabal update. What's it doing? Why do I need to do this? Well, it's simply going to go out to Hackage. It's going to fetch the most recent versions of the packages that are out there and download it so you can query it through the list command. And you can run this anywhere on your system. It doesn't matter. And using the verbose flag that typically comes with a lot of these tools, you could, sorry, you can see exactly what it's doing. So if you have any question, or maybe there's a new feature, I mean, I don't think this one in particular has been updated in a while, but you can see exactly what it's doing. So it's simply doing a get to HackageDB, and it's coming back with the results, caching them locally. And then you can use the Cabal list command to check out exactly what's out there and what the latest versions are. So Cabal list, it simply takes a single command line argument. That argument is going to be a string that's going to match on the package name and provide you with a list of packages that match that string. Some of the default information that's provided here is stuff that's present through the description given to Hackage by Cabal. Synopsis, which is a simple description, typically a one-liner of what the package does. The default version that's available, which is the version that's going to be downloaded if you don't provide some sort of constraint, as well as it'll tell you whether or not you've currently got this package installed. And again, you can run that anywhere. And let's see. Cabal also provides you the information you need as far as like whether or not you should be updating the package, your packages. It'll warn you if things are out of date. It'll also remind you or tell you whenever Cabal install needs to be updated itself. So once you have this list of packages, you might go through it and kind of wonder exactly what packages, or you might want to grab some of these packages and kind of see what they're doing, install them locally. And Cabal install is the command you'd use to do that. It's also going to take a single argument, which is going to be the name of the package that you're going to be downloading and installing. And what that's going to do behind the scenes is it's going to grab the library or executables dependencies. It's going to grab that, whatever dependencies, and so on and so forth. It's going to build those, install them, and register them locally. And it's going to put these in a common place for all the installs. So we can take a look at some of the output as far as what that's doing. So here I'm installing Snap, and it's going to go through and resolve the dependencies. The first thing it's going to see is that it needs also monad catch IO transformer. It's going to grab that. It's going to compile its modules, and so on and so forth. And on down the chain until finally it gets down and it realizes that it has all the dependencies it needs, and then it's going to install Snap itself. And you can see right here, more or less, whoop. It's kind of a neat pointer. You can see right here exactly where it's installing these things. So you have the install of the executables, and again, I'm on a Mac. Depending on your OS, it's going to be a different location. So the executables and then the libraries themselves. So once you've done that, maybe you want to get your hands dirty and kind of see what some of this code is doing. And Cabal offers a nice command for doing so. It's called unpack. Simply, you'd want to go to whatever directory that you typically would download source code to, and just run the unpack command. And what that's going to do is, if you don't already have it downloaded, it's going to download the source for you, create a version directory, whatever version of the source code it's downloading, and drop the source code right there so you can go and check it out with your favorite text editor, see exactly what it's doing. And again, some sample output of what that's going to do. You can see it. And then once you've got that, say you're on a plane or something and you don't have access to the internet and you want some documentation on what the code's doing, maybe you're using a library and you're not exactly sure what the module exposes or something like this, you could just generate the documentation right there using the Cabal haddock command. It generates some very nicely formatted HTML that we'll see a little bit later. And it's going to drop that into the dist directory on the root of the package. So let's see what else. So once we're done kind of exploring the packages that are available through Hackage, maybe we want to go ahead and develop our own. And there are a few simple commands that you can use to get started as far as how to do this. The init command, and then so on to build and configure your code and run the test suite. So what does Cabal init do? Okay, well, this is a really helpful tool, but it's simply just an interactive command for generating your .cabal file. So the first time around, this can be a little daunting, maybe. Maybe you're not sure exactly what some of the fields are and what's required in some of the fields. So it's going to kind of guide you through that. The first thing it's going to do is, well, it's going to go through and guess some of the obvious information. So you're going to want to make a new directory for your package, cd into it, and then run Cabal init. It's going to guess the name of the package based on the directory. It's going to apply a version number, and assuming it's a new one, it's going to apply something necessary for that. And it can also do some guessing as far as the author and maintainer, I believe, depending on if you have darks installed and configured. And I think there's actually a patch coming out that will also guess the maintainer based on your Git config. But anyway, and it does a lot of other things. It's going to, here are a few example prompts that it's going to give you. As I noted before, some of the other options, it'll give you some fairly standard options here. So we have like your license option. You can choose one of these, and when you do, it's actually going to template and generate a license for you and plug in your username as well. So it's kind of nice. Some cruft work that you don't have to do on your own or copy and paste. And then some of the later options that it's going to give you is whether or not you're going to be building a library or executable. Of course, you can build multiple executables or a library and an executable in the same package, but it'll give you the choice. You choose one. And then also the final option is whether or not you want to be verbose in the output of what it's going to write to the .cabal file. And this can be quite helpful in providing some of the descriptions. It'll also provide some of the stubbed out to-do required fields for some of the target sections. So now I'm going to kind of step through some of the fields that Cabal expects in its file. The .cabal file is a declarative description of what your package is and how it's built and the general structure, and it also provides a lot of top-level information on what the package is for Hackage. So it can provide the links that we need, as well as some of the other dependencies and link to the dependencies. It also provides some other build information, as well as flags and conditional building, and also the core package descriptions. So top-level description, we kind of went through this already, but we got the name, the version, the synopsis, the description, which is just a longer version of the synopsis, and the homepage and so forth. All of this is going to be used by Hackage upstream to generate those links. Hackage will complain about some of these not being present if you try and upload, like the source repository at the bottom. And so there are other build descriptions that you can use as well. These are necessary. It gives you'll need to give it a build type. In this example, I'm using simple. You could also look in the module itself to see what other build types are available. You can use custom build types and other more advanced things, but we're going to stick with a simple example. So to get something up and running. And then the Cabal build version, this is going to give you the lower bound of Cabal that's necessary to run this file. And then you can also describe some other extra source files. And I'm cutting a lot of these descriptions out that you'll probably encounter along the way. These are just some simple examples. But that's going to be other files that you're going to need to package with your distribution. And here are a few other build fields that are also going to be necessary for the other sections in your Cabal file. These build fields describe what you need to build your package, to build the various targets. In this case, base is going to be the base Haskell standard library functions that you're accustomed to using. Then you have some other semantic versioning. You can declare an upper and lower bound here. You can also use the wildcard syntax so this line is equivalent to the previous line. And some other examples of things that have subfields. You have other modules as well. That's going to just define modules that will have package level visibility, and will compile, but they're not going to be exported as part of your API. And some other flags and other tokens that you can define. And we'll kind of see these again later. And now I got the one of the things that you can define locally. Oh wait, no, you can do conditional builds. So you can use the conditional thingy to make a build. This is doing a conditional dependency on what GHC is. So if I'm going to use a version of GHC that's not quite to this number, then you're going to want to include a build dependency for a byte string in this range. Otherwise, you're going to go with something a little bit higher. And then you can also define your own conditional thingy. And you can define that at the top level, which is just a flag. You can add a flag and define it with a distinct name there and give it a simple description and a default value. And then you can provide some custom conditional logic within your section's definition in the .cabal file. And overall, you're going to want to use these when you run configure. You can provide a flag, which is just going to flip that bit, and do your conditional. Sorry, this thing is kind of. And yeah, so I was jokingly using the word conditional thingy, but this kind of describes the documentation that's sometimes out there for various tools. So it's kind of our duty as Haskell programmers and programmers in general, when we see these sort of things, to probably clean them up and be good Boy Scouts. But anyway, I just thought that was kind of funny. So we can now go on to describe, I guess in greater detail, what the different sections of the .cabal file are. This is going to define the different individual targets for the Cabal build. And it's also going to give you, sorry. But what it doesn't do is it doesn't describe your code structure itself. There's a nice link here, and on, well, I won't go to it, but you can Google it. It's Haskell code structure. Anyway, so the first section that we'll probably want to get acquainted with is the library section. The library section just describes a module exposed as your external library's API to the consumer out on Hackage. And it requires a single field. That field is the exposed modules. And here you can see that I've defined a few, Enterprise FizzBuzz, and Fizz and FizzBuzz. And then you could also define other modules, again, package level or visibility. If you don't define if your modules aren't included in either one of these, they won't get built. And also, just simply a beginner's trap is accidentally adding the .hs to your module name, and then it will not build. The next section is the executable section. This defines a target that's going to simply create an executable that you can run from the command line. It requires a couple of things. You need to ensure that you have a unique identifier here, and you also need to ensure that you're providing it with the main is field. And the main is field is just where the main module is going to be located. And again, I'm using these other descriptors or other fields. HS source dirs, that's going to say you can search anywhere in this directory to try and find the main, or you could just give it a direct path to it as well. And yeah, as I said before, you can certainly define more than one executable in your .cabal file. So. And the next section is the test suite section, and we're going to see this later as well. It requires also a unique identifier in its main, but it also it requires a type parameter. Here I'm using exit code standard IO1, and then you also have to give it the package that you're going to be testing as well. So this is simply an executable that indicates failure with a non-zero exit code. And again, you can define more than one test suite. And so now, very similar to the test suite section, you have a benchmark section. Again, you're going to have to give that a unique identifier as well, and a type, standard IO1, I think is the only one that's supported, and also the package that you're going to be benchmarking. And again, you can define more than one of those as well. And we could take a look at a complete file. Whoops. I'll do that at the end. So we can take a look. I've got a skeleton example project that we can take a look at and see how it works. So now that we've got this all defined, we can write a simple program. And the problem that I decided to solve, which is solved many times over via the internet, is the FizzBuzz problem, which is simply print the numbers between 1 and 100. If it's evenly divisible by 3, you're going to print fizz. If it's evenly divisible by 5, you print buzz. If it's evenly divisible by both, you print FizzBuzz. Pretty simple. So we're going to go ahead and flesh out what our main is. So in our main source file, we would have something along these lines for one of the executables. I'm not going to do it by the book. I'm actually going to have the user tell me how far to go, what the limit of FizzBuzz is. And then it simply takes that. And we could define another one for our second executable. And that's going to take a number and just return the fizz or buzz or the number itself, whatever the user decides to put in there. And then we can go ahead and stub out our module. Now this is going to be our business logic. And here I'm using the type system to verify that all of our type signatures check out, but I'm not actually providing the implementation. So later when we go back and test it, we can see that it's going to certainly fail. So next up, how do I go about running this code that we've just written? Well, first you're going to have to run configure. What's that going to do? Well, that's simply just, it's going to be packaging your build. It actually does a lot of preparation. It's going to check to make sure your dependencies are there. It's going to decide which tools to use. And it's going to tell you when certain dependencies aren't present. So you're going to want to run that in the root of your package. I mean, that seems pretty straightforward. And once you've gone ahead and configured your build, you go ahead and run it. Running the build will just create the dist build directory structure. It's going to take every one of those sections. It's going to build them up, package it, and put it there. And then you can actually run your executable from that dist build directory. And one of the other things to note is if you run build without configure, it's just build implies configure, so it's going to rerun configure, but it's going to use the same options that you most recently used. So what happens when I run this? Well, of course, it's going to error out because it's undefined at the moment. So we can move on to how do we test our code? Well, how do we go about writing test structure? And I'm not going to preach about TDDing versus not doing it or whether or not that's effective, but for me overall, I found it to be relatively effective, and I wanted to, I guess, go about this talk in that way. So we're going to use test framework, and test framework is a tool used to, you can use it with both quick check and HUnit. It'll run your tests in parallel. It ensures that your test results are returned in a deterministic order. That means given the same tests, you're going to get the output in the same output, or the same output in the same order, so they're deterministic order. And it also provides a nice syntax for grouping your assertions and writing your assertions. So HUnit itself is an adaptation of JUnit. It's going to provide a simple syntax for writing these assertions. And simply, assertions are just types that, when evaluated on failure, they're going to output a message for you. So some functions for generating assertions. We've got assert equals. These are pretty standard if you've seen a unit testing framework before. Assert equals just takes a string, which is a description, and then it's going to provide the expected value. Of course, these are both going to have equality and show, and also the actual value. So, and then it'll output the assertion for the test framework to use. Here there are also defined some operators. These actually don't have a description, but it makes it nice and terse if you have various equality comparisons that you want to do on your test data. And here the question mark is the actual value. The equal sign is going to be the expected value. So you'll put, I'll show you an example in a second. And then the final one is predicate. So once you have HUnit assertions, you can use test case to bundle those up into tests, and that's going to give it further description with a test name. And so test case just takes a name, an assertion, and then generates a test given that. So, so that's what we've got. And then we can also use a test group to take a name and give further description to our tests. And it'll take a whole group of tests and create a source that we can then execute on. So this is a simple example of some tests that you might write using HUnit and the test framework and test provider. So test case is the function that's going to generate. It's going to generate the test from the given name and assertion. So down here we've defined a few assertions using the operator in various forms, and also assert equals with a little bit more description. And these are going to output a list of assertions. And up here we have a test group that's inevitably going to fail because FizzBuzz can never return not here. And then the other group, which should pass overall, which just defines simple assertions that FizzBuzz1 is going to output the string 1. And then also FizzBuzz3 is going to output fizz. So some simple test cases. And we can go about running those very simply using the Cabal test command. And in order to do that, we're going to have to pass the configure flag enable tests and then rebuild our project. And then once we've done that, we can run test. And of course, it's still going to fail because we haven't provided any implementation for this. So it's going to report the failure in a very expressive manner for us. It's just going to say the FizzBuzz unit test cases. and this failed because of the undefined that we get here. And then if you want to turn off the test building, you're going to pass back the disable test flag. So we can easily make these pass by providing some implementation here. I'm not really going to go into too much about what this is doing, I guess, but simply takes the integer, and mods it by 3, returns fizz, and then does the same for 5 for buzz, and concatenates the 2. And I actually grabbed this off of Haskell quiz. I didn't write it. I mean, I know 1,000 people have already written this in Haskell. So this actually belongs to a guy named Mike Bethany. I don't know who that is. He might actually be in the audience. And so once we have this implementation in place, then we can rerun our tests and see exactly what's going on. So we get some nice output here. We get our tests that we expected to fail. We see the expected value not here, which is obviously not going to be there. And it should have been buzz, which is the actual correct answer. And then should return 1 passes, should return fizz passes. And then it gives you a nice tabular form of the tests and which ones passed and which ones didn't, or how many passed and how many didn't. And then overall it says our single test suite has failed. So some nice output. And now once we have something that runs, maybe we want to actually install our own project and run it from the command line without having to go to the dist build directory and run it that way. So we can simply just call command Cabal install, and that's going to operate on your local package the same way it would have if it downloaded it from Hackage. And then, so whenever you want to be able to execute any of the things that you've currently got installed, you're going to want to add them to your path. My specific path is here, but you're going to want to add that to your bash profile or bash RC, whatever. And that's what we get. So now we can just call our function from the command line, or our executable. So now that we have a simple test in place, maybe we want some better confidence about our performance, our code's performance. So we can use a library called Criterion for this. And what that provides is an easy to write and build syntax for benchmarks. And it can hook up, it can provide a way to define IO and pure benchmark actions. So it also provides some very nice graphs for further inspection, which provides the standard deviation, mean, and some nice graphs so you can see the outliers as well. So we can simply construct some benchmarks using the special syntax here. And benchmarks are simply just one or many benchmarkables. That's a type class that defines a single run here. And we have 2 functions, or we have 2 instances of benchmarkable, both pure and IO for testing pure and IO functions. And then the bench function itself is going to take one of these benchmarkable instances and a string descriptor and return a benchmark. And then we can further group those using bgroup, another string for the group's name and description, and then build those together into a benchmark. So whenever you're benchmarking a pure function, you have to be aware that it might not actually be evaluating your code. So here you're going to, it also is going to be providing a normal form and weak head normal form functions that return the pure benchmarkable instant, or benchmarkable at the end. And simply, if you're going to be writing a normal form, that means that you're going to want it to evaluate the full structure, and as opposed to just evaluating the outermost data constructor. So here is a simple example of how to write some of these benchmarks using the tools that I just described. You have the B group that's just grouping together these benchmarks. Again, you're returning a benchmarkable here, which is a function, our function call with its argument, and it's just a simple description on the other end. So this isn't a very exciting version of benchmarking something, because clearly these are going to be pretty straightforward. The execution time of these functions isn't going to vary too much, but just a simple example of how to write it. And then you can run your benchmarks simply by passing the configuration flag, again, much like our test suite example. Configure bench enable, and then building it and running bench. And then you can also disable it in much the same fashion with the disable bench flag. And so what this gives us is a nice command line output of that could easily be parsed to do some automated checks, and there are probably tools around that could do this for us. It's very descriptive about the outliers itself to give you like some idea of how your computer may have affected the outcome. So here we have the FizzBuzz head normal form version running at 100. It has a mean time here and the standard deviation. And then down at the bottom, we see that 12% of the variance introduced was via the outliers. So it's probably like watching YouTube or something while I was running the test. And this tells you exactly how much it might have been inflated, so, or to what level you should be concerned. I don't really exactly know what the limits are there, but yeah. So if you want a better visualization of exactly what this is and what it's better visualization of what this is, you can simply run the dist command here from the command line with the output flag and give it a target to dump the HTML into. And what this is going to do is it's going to plot a nice histogram of all the points and of the executed samples. And it's going to do some smart plotting. It's going to bucket these appropriately and make it very obvious where the outliers lie. And also, the most important thing, it's going to impress your boss with how fast your code runs. So, and
the math behind criterion is actually also kind of neat.
sorry? Oh, yeah.
It also, you get really, really precise, robust measurements. It's really good.
Yeah. No.
Like, if you're not using criterion to carry performance, shut up.
Yeah, it is kind of the standard tool for this that's available. So you can actually see some of these benchmarks. There we go. And so you can see at the top the head normal form version of it. Certainly performs a little bit more poorly, but you can see your mean here. It's got some on hover actions as well. So there's your mean. And then you have some outliers further out. And then some of the same data that we had seen before as far as the lower and upper bounds of your runs. So, and then a little bit more information. Brian O'Sullivan's done a great job of documenting exactly what this web page means. It's all at the bottom here. So, there we go. Can't seem to get out of this. Oh, there we go. And let's see. All right. And so now that we've gotten our benchmarks in place and we've gotten some tests written and gotten our code running and compiling, we can go ahead and prepare it for upload and package it. So the first thing we might want to take a look at, and I know this is kind of difficult to read, I'm sorry about that, is we want to generate some documentation. And again, we can go back to our tool, Cabal Haddock, which is, again, going to, from your top level, create a nice simple HTML file that describes your package, and you can also add some kind of markdown style-ish tags into your code. So here, if you could read it, it actually gives you a description of the content, a tag at the top that you could click on, and it'll bring you to the place in code. And this is defined in your definition of what the module is and where it's and what things are exposed here at the top. So the top level description, and then further in your code, you can add some other comments, including just straightforward comments. So this is just a comment. It's got a single pipe here. And then later you use an angle bracket, or I have an angle bracket here, which defines some code text style stuff that will be output for the documentation. And oops. So run Cabal Haddock, and you get some nice documentation here. And you can click on the link to our code. And these are just for padding mostly. But the comments that I'd put at top when defining the module with the various function names appear up here. And if you click on those, it's going to drop down to the definition itself. And again, this is just simply using this function in the main module. So these are just simple comments, but it's kind of a nice thing to have. And if you're aware of it, then you can provide better documentation for your code. So let's get back. Oh, crap. All right. And then once you have the documentation in place, you can go through and use Cabal sdist. And what that's going to do is it's going to create a tarball. It's going to take all of your source files and everything you need. It's going to and it's going to package that all up and put it in our dist directory for distribution later. And once you have that tarball, and some simple output. So whenever you run sdist, it's going whenever it's going through and compiling, it's also going to do some simple checks to make sure everything is there for hackage. So when you're uploading to hackage, certain things are necessary again. So here it's warning me that the source repository field isn't available, and it should be. So it's telling me to go back and check the user guide and make sure I have that. And for those who want to give back to the community, you can just use the Cabal upload command. This requires a username and password. In order to get that, you're going to have to email someone. But all you have to do is simply pass the tarball to the upload command and give it your username and password, and it's going to try and upload it for you. So hopefully that simple talk through how to build a Cabal package from start to finish might help some people out when they're first getting used to the tool itself. And of course, there are some, if you want to read the documentation on Cabal itself, you can easily just unpack it and then cd into the directory and run Haddock. And then you have all the documentation there for you. How are you guys? So I guess now I'm just going to, does anybody have, oh yeah, I promised you guys I would show you this other thing, but I just got this MacBook, and I'm not even sure how to get out of this full screen mode. So, yeah, escape seems to just send me out. Whatever, I'll just do it this way. Do it like that. Top right. Stupid MacBook. Yeah. And all the source code's available. Like I said, you can.
And if they work, they'll take them. And there's some really nice sandboxing that'll hopefully be in the next major release.
What the hell? I was trying to get out of this. There we go. And easily take a look at some of our source code. So So here's a full Cabal file that I was going to link to previously, but yeah, this just defines the package, the top-level package, the two executables that I described, the library, the test suite, the various build dependencies that I was using, and the benchmark there. So I'm going to go ahead and I'll put that up on Git in case anybody wants to look at my skeleton project. Other than that, does anybody have any questions? Simple anything? Yeah? Yes? I can't promise I can answer all of your questions, but I'll try my best.
I guess you said that you could build libraries or you could build, what's it called?
Executables?
Executables. And could you say a little bit about library structures? And I mean, I always building the library from scratch when you have an executable. I mean, I remember in my old Windows days and where there was always a lot of different ways that you could build libraries and like different linking strategies. And I don't know how that works with Haskell.
Yeah, of course there are different strategies with building things. I mean, there are plentiful different tools that you can use to do dependent building. I don't know exactly which one you might be referring to, but what do you, specifics? Yeah. Okay.
Haskell is, or GHC Haskell. Haskell is a language. It can be interpreted. It can be whatever. The libraries GHC builds are very, very tied to static linking because it does a lot of cross-module inlining and optimization that gives it its very good performance. And that means that you've got sort of very strong version bounds, which is why having good control of the stuff like Cabal does is quite important.
Right.
And you can do split objects and not just, build one binary for your library, but, spit out like, a zillion ones, one per module. But even then, it's all heavily cross-module inlined for performance purposes, if that sort of answers where you're coming from.
I mean, so there's both dynamic linking and static linking options. What Gershon is referring to is the fact that if I can't give you a dilib that I built and have it make any sense for you to run if you have a different version of GHC. So there is both dynamic and static linking choices, and but by default, people have historically been using static linking partly because it worked more consistently. Although dynamic linking options are better now, and there's certain improvements relating to that. They'll actually tie into certain quirks of GHCI acting funny on certain platforms going away, hopefully in the next major release or two for GHC. And that relates to GHCI having its own linker historically that would do dynamic linking of static objects. But now we have pretty wide platform array of dynamic linking actually working. But so that said, even though you have dynamic linking as an option, sometimes it's nice to statically link a binary and just deploy it somewhere. And that's just emailing someone a binary or just uploading it to a server is a great workflow. For local dev, dynamic linking can be nicer. I mean, there's an infinite discussion going around. Does that kind of answer your question?
Thank you.
Questions?
You mentioned link to like a recommendation for structuring your code
Oh,
for
right.
Haskell. Is there like a standard for that? Is there one?
Yeah, I was just looking online, so go to. I did have a link. Hold on. There we go. Anyway, yeah. I mean, hold on. We'll go back over here. I should have provided that at the end as well. But, sorry. I'll just, oh, there it is. Okay. So this guy, I just found this. I mean, it's pretty simple, the recommendation, but this is the recommended structure that Haskell promotes. I mean, one of the things that I think would be nice with the Cabal build tool itself is to provide a scaffolding command feature so that we don't have to go through and set up a structure like this on our own. I mean, most of my talk was just how to set up the structure and what dependencies you need to test and stuff like that, how to write something functional. So it would be nice to have something that would scaffold that and put your test framework there for you. Maybe it belongs in Cabal, maybe it doesn't, but nice to have. Sure.
Anyone else? Thank you again for a great talk.
Thank you.
Cabal has got more features than any of us know how to use, so